Good morning, everybody. We are going to do some transformations. These are just going to be a little bit different than the transformations that we've done in the past. So um, I am going to do this whole first example. They're kind of involved, but I want to show you all the different pieces. So we are trying to graph. They give us this blue line as f of x. And then we are trying to transform it into g of x. So g of x is a transformation of f of x. It's just like when we did a of b of x kind of stuff, where you are plugging one function into another one. So it's a little bit different than if I just said g of x is 1/2 x minus 4 squared plus 3. Then this would tell you the vertex, and then this would be the stretch. But that's not how this works, because f of x is already a certain kind of function. In this case, it's an absolute value function. Just wanted to give you something, show you something a little different. That's another function type. That's what these bars mean, absolute value. And you can see that this vertex is at -3, 3. So still the same thing. You got h and you got k. And then you have this number here, or this value here, the a value, down 1/1. Okay, so what do we do with that? It says create a table of x and y values. So x and then f of x. That's what we're gonna do here. F and x, or x and f of x. And I'm gonna start, so I want to include the vertex. That's gonna be like my center point. We're gonna see that symmetry on either side of the vertex. -3, 3. If we back up, we'll have -4, 2, -5, 1. And if we go forward from there, we'll have -2, 2, -1, 1. So we're just trying to get, 5 points or so that will help us see trends and relationships between these x and y values. Okay, so we have done this part. Then it says use the equation for g of x in terms of f of x to create a composite function. So I think that this is probably what we should do next, because you guys are so solid at it. Well, I'm not going to be able to highlight that. So you see in here we have f of x minus 4. So here's f of x. What would f of x minus 4 be? And I'm not doing anything with the 1/2 yet. I'm not doing anything with the +3 yet. I'm just focusing in on what is f of x. I need that to be somewhere else. Just want to know what is f of x minus 4. So it's going to be negatives, same thing, absolute value sign, and then that is where we plug in x minus 4 for that x value. Instead of x, now it's just x minus 4. And then +3, close the absolute value, +3. And so f of x minus 4 is equal to negative absolute value of x minus 1 plus 3. So what does that do? This is another h value. So it's an h value that transforms a previous function, but it does the same thing to it. It's going to move it to the right 4 spaces. So that vertex, which was at -3, 3, moves over all the way to 1, 3. So it does the same thing to the vertex. Now, the next step, you've got, we have to do the 1/2 and the +3 now. So all of this, if we want to put the 1/2 in there, we want to do 1/2 of that f of x. That means that includes or involves multiplying this whole thing. So we have to multiply that whole function. And if you'll notice, I'm using the order of operations. So I've started with parentheses, I'm multiplying now, and then I'm going to go to do the addition. So when we do that, we get -1 times 1/2 is -1/2. Absolute value of x minus 1. We treat those like parentheses, so that 1/2 stays on the outside, it doesn't go in there. And then 1/2 times 3 is plus 1.5. Okay, and then from there, we now have to do the plus 3 part. So this is 1/2 f of x minus 4. Now we need to add 3, and that just means we're going to add 3 to the end here. So negative 1/2 x minus 1 plus 4.5. And that is g of x's function. Whoops. So the first thing it asked us to do was find g of x, or the second thing it asked us to do after the table is find g of x, and there's g of x. And we know enough about transformations that we could go, from 0, 0, you could go over 1, up 4.5, and say there's the vertex, and then down 1 over 2, down 1 over 2, because it's an absolute value function. It kind of acts like a linear function in both directions. Okay, but let's see. Create a composite function. Good for us. Next up, transform the points in your first table. That's these points right here, to get a new table. And this is the part that's quite new. And so I want to do my very best to give you all that info right now. So this is going to be the new values for x and g of x, the new function. Remember, it's a transformation of this function. So we have the points, we have the values a, h, and k. Remember, h transforms something left and right. Okay, so left and right affects your x values. So the h value is what's going to change these things. And then the a and k value, a is a stretch, vertical stretch, and k shifts it up or down. So those affect the y values. Your a and k values are going to go here. So what do we do from there? We're just going to apply all these transformations just like we do when we're graphing one function. So you look at the f of x minus 4, that's a shift to the right 4, right? So if I shift a negative 3 to the right 4 spaces, 1, 2, 3, 4, now it would be a 1. So we're just going to add 4 to all of those x values. So plus 4, plus 4, plus 4, plus 4, plus 4. Negative 1, 0, 1, 2, and 3. So those functions are all shifted to the right 4. It's like these points, this point on the graph is going to move somewhere else. And we want to know where it moves. So we know that it shifts to the right 4. Is this right? It shifts to the right 4, whichever way it's supposed to be. And now we look at the a or the f of x values, and we do a and k to those things. So here's your steps. You're going to multiply by a and then add k. So that means we're going to multiply by 1/2. That's a. And then we're going to add 3. So 2 times 1/2 is 1 plus 3 makes 4. 1 times 1/2 is 1/2 plus 3 is 3.5. Now, this is an interesting point because this is the vertex, right? Vertex. So that means it should still be the vertex when it gets over here. And what happens if I take 3 and I multiply it by 1/2? That's 1.5. And then I add 3 and I get 4.5. 1, 4.5. So look down at your g of x equation. That's exactly what you would do for the vertex if it just said graph g of x and it gave you g of x's equation. You would go right 1, up 4.5. So transforming each individual point works just as well or works the same way. Then 2 times 1/2. Hey, look, we've got symmetry. Remember symmetry? Okay, so if we start with 2, we get a 4. Start with 2, I get a 4. We start with a 1, we get a 3.5 times a plus k. So here are my new points. So rather than just going and trying to graph an absolute value function, I've given you the points. We're transforming the points, and now we can graph the new function. My room is telling me I'm not here anymore. Rude. Okay, so we go -1, 3.5. 0, 4, 1, 4.5, 2, 4, 3, 3.5. And so the function's going to look something like this. And that's g of x. You've done it. Congratulations. So use the graph of f of x to graph g of x. Done. So what has happened to the f of x function is it's been shifted over to the right and it's been shifted up. But if you'll notice, the over to the right amount is 4, but the up amount isn't 3. It's half of 3. So it only goes up 1.5, and that's for the vertex specifically. But each point, just remember order of operations still applies. So when you shift your a value or your y values, your f of x numbers, a goes first because we multiply by a, and then k comes next because then we just add k to it. So that is the whole first example. You are somewhat ready to attempt some more. And if you're still here, maybe that means that you're panicked about it. So I'm going to at least start number 3 for you. Don't tell your friends. Just act like you know how to do it. Okay. It says f of x is graphed below. It gives us a graph. It says determine its equation. Rude. That was me. I'm sorry. But we can do that. We know how. So from the vertex, we know the vertex is 0, 2. Trying to practice this skill still. And so that means that if you are writing f of x's equation, it's going to have x squared in it. Okay, I put parentheses, but there's nothing in the parentheses because it doesn't shift left or right. Then there's this plus 2 that's going to go at the end. And then what number is a? I've told you multiple ways to find that. You can take another point and plug it in for x and y and solve for a. Or you can say in this one, you can go, okay, that's down 1 over 1. So it's going to be -1. So -1, x squared plus 2. That's f of x's equation. And I'm going to make a table of values, x and f of x, because those directions still apply to all these problems. So starting with, I'm going to start with 0, 2 in the middle, because that's the vertex. I want that vertex point to be in my table. And then I want a couple points on either side of it. So I see this point is -1, 1. 1, 1 is on there. And then when x is 2, y is -2. And when x is -2, y is -2. We've got, again, you got your vertex here, and then you have, wow, great lines. And then you've got nice symmetry all around it. Okay, so let's start by transforming these points. I will transform most of them to f, or to x and g of x. Okay, so we have to ask ourselves, what kind of transformations do we have? We have an h and we have a k, but we don't have a new a value. A is still 1. What that tells me is that the shape of that function is still going to be exactly the same. It's just going to move somewhere, up, down, left, right, something like that. Okay, so what changes the x values? The h value does. Okay, and what is h in this case? Well, if it says x plus 2, then that means it must have been a -2. We need to shift to the left 2. How do we shift to the left? We can just subtract 2 from all of those points. We get -4, -3, -2, -1, and 0. They follow the same pattern that these are going to follow. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. No gaps. All right, now we transform the y values, and it's a -1. So we just subtract 1 from all of these. It's going to shift them all down 1, -3, 0, 1, 0, -3. Whoa. Whoa. Okay. Sorry, I'm crazy. And those are our new points. You can just graph those. And then I want to do the part where we compose, because I imagine that there's still a little sketchiness about that. So if we know that f of x I'll rewrite f of x over here, is negative x squared. And I'm going to put parentheses there because that negative sign tends to give us problems. Only the x is being squared, not the negative sign. Thank you. I'm into my TED Talk. So now g of x is going to be f of x plus 2 minus 1. So that means in f of x's equation, we don't want f of x, we want f of x plus 2. So we're going to plug in x plus 2 into all of those. So g of x is equal to negative x plus 2 squared plus 2. So this equation is exactly the same, except now we have x plus 2 in there for the x. And then what do we do with this minus 1? Just add it to the end. And so g of x has an equation, and that equation is negative x plus 2 squared plus 1. And if I graph that the old school way, negative 2 up 1, and then down 1 over 1. So we got 1, then we've got 3. And let's check those points. So I've got negative 4, negative 3. Donezo. Negative 3, 0. Got it. Negative 2, 1. Got it. Got it, got it. Okay, so again, the function is the same shape. G of x is the same shape as f of x. It is just shifted to the left. So left 2 comes from here, and then down 1 comes from here. You can do the rest, challenge yourself, help one another, be good.